All right, let's go ahead and get started. So just some general reminders. We have homework that's due tonight. If you go to the homework page, you'll be able to see the turn-in link for the homework for tonight. I have put up homework 2, which I'll pass out in a minute, with information about the homework we're going to do for next week. Reminder about the output comparison tool lets you make sure that you have the correct output. I'm going to show you that in a second because it'll be a way of introing what we're going to do in the lecture today. But also reminders, TA IPL schedule you can look at to see. There's people there, 12:30 to 9:30, tons of TAs to help you on the 3rd floor of Mary Gates Hall. So if you're having any kind of problems with anything, that would be a great place to go to get some assistance. Message board if you had questions that you wanted to have answered about the homework. And then remember this little sections tab is the way to see what the section homework is for tomorrow, the little thing we want you to do to warm up to get ready for section. Under the output comparison tool, so as we go through the quarter, I'm going to add more and more things here. So I can just kind of show you briefly that you're going to be creating output that looks like this. It's a little rocket ship kind of output. But it's not going to be like chapter 1, where we're going to just say println, println, println of an exact bit of output. We're going to do it in such a way that we could change it, say, to that rocket ship, so that we could scale it to be bigger or smaller. That's going to be the challenge of what we're going to be adding in this second homework. And we're going to use loops in order to do that, so that we're not going to say println quote everything on the line unquote. We're going to do the little parts of it piece by piece inside of loops, so that the loop can go a different number of times, so that it can make a big rocket ship, a medium rocket ship, a small rocket ship, and so forth. I'm going to do a specific example with you guys, so it's this little mirror example right here. And what I'm going to do is a mini version of what you're going to do in your homework assignment. So I'm going to kind of, in going through the lecture today, it's an example of what you are going to do in writing your program, just kind of going through it step by step. So let me switch over to JGrasp. I've put the output here, kind of that mirror. This is kind of the first version of it. There's a different version of it, which is a slightly smaller mirror. So we're going to get to that in like the last 10 minutes of class. But we're going to kind of begin with this little output right here. Now, NTAs, we can start passing out the assignment right up now. So I'll go ahead and let you guys, you'll be able to take a look at the rocket ship homework. The first thing that you're going to want to do is look at these various lines, and we want to figure out which ones of them have a pattern that's common. These lines fit together. A little bit like Sesame Street, right? One of these things is not like the others. So that first line of the output is very different from the lines that come after it, although that line of output also appears at the end. So that's kind of a certain kind of output that we're going to have to be able to produce, but it's different than the other parts. So this is one thing to notice. Now, the lines that we have left are all very similar, but one of the things that is true is that you kind of see something happening here, right, where the dots are getting more and more and more, and then it's kind of the dots are becoming less and less and less. So there's kind of it's going in one direction and then it's going in another. Maybe you could write one for loop that would do that, but typically what we would say is that's two different patterns. That's kind of the dots going up part and the dots going down part. So, just kind of a quick analysis of this output, I would break it into these different sections, and I would plan on having a method for each of these different kinds of sections. Just like we had a method for a verse in homework 1, I'm going to want to have a method for these different parts. So I kind of know that the way my main is going to look is that I'm going to want to draw a line of output, that line that has all those equal signs on it. I'm going to call it draw half 1 and draw half 2. These are those pieces of the output that have those lines where this is the half 1, this is going to be half 2, and then we draw that line again, and we can just call the same method twice, so we can draw that line afterwards. So I already kind of know that's what I want the structure of my main to look like. This is a little bit like the way they tell you you're supposed to write your English papers, right? You're supposed to write like your outline first and so forth. You actually can code it this way even. We can say public, static, void, draw line, and we know it has a set of curly braces. Public, static, void, draw half 1, and we know it had some curly braces, public static void, draw half 2, and we know it has some curly braces. We don't have to fill in the details yet. We can just kind of put a placeholder there, right? It could just be empty for now. This technique actually has a name. People call that stub programming, that we're making kind of little placeholders for those methods, but we're not saying yet what it is they're supposed to do, but there's kind of something there that's going to be expanded later. And I even have the ability to, let's compile it, and make sure I didn't make any errors and run it, and it doesn't do anything, but hey, now I get to see that it doesn't do anything. One of the things that I really wanted to emphasize in the way I'm going to present this to you in lecture today, but I'm also just going to mention this over and over again this quarter. The textbook mentions this, the TAs will mention this, and so forth. But one of the things that probably the single biggest problem that novices have is getting overwhelmed with details. So you look at this picture of the rocket ship and you're like, oh my God, how will I ever make it do all of that and make it scale? So, your brain explodes because there's just too much detail to deal with when it all hits you. So it's very important to have approaches that allow you to break down the detail into stages. That you do a little bit of the program, you compile it, run it, make sure it works. A couple of people over here need the handout. And then once you know that part works, you do a little more, make sure that works, do a little more, make sure that works. That's how you manage detail. So you want to do it, piece by piece by piece, not everything at once. Don't try to write out all of the code for this rocket ship program and then take it and then type it all in at once. Get little pieces of it to work first. Guys, I want you can hold your hands up if you need a handout, because it looks like some people didn't get it. And there's a few other extras up here if you run out for whatever reason. Okay, let me switch back over here. So what I'm going to talk about next is I wanted to mention an idea that's in Chapter 2. Chapter 2 mentions the idea of using pseudocode. It's a technique that programmers will kind of use as, what do you write down on a piece of paper or whatever? How do you approach something? That it's a way of kind of sketching out a solution slowly but surely. You kind of, just write down an English-like description of what you're doing and then turn it slowly but surely into something that looks more like code. Like if I wanted to describe in English what this is, draw a solid line or something, I could say that. That's not very close to code, but that's kind of what I want to do, right? But maybe if I wanted to be a little more specific about what it means to draw a solid line, I'm actually going to be giving printing commands. What do I print first? What gets printed on the line first? The hashtag, right? Isn't that that's the very first thing that gets printed on the line? Then what gets printed next is some equal signs, right? So I'm going to say print some equals happens next. Then what? After we do all of those equal signs, there's going to be another hashtag. And now, one of the things that you're not going to be used to, because we only did it a little bit at the end of Monday's lecture, but we're going to be using print commands instead of println. We're going to say print, 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 so that it all stays on one line of output. The print keeps it on the current line of output. But you are going to have to, at some point in time, do a println, that completes a line of output. But you only want to do it once. So for this line of output, we want to do all of our print to get all the characters, and then one println that will complete the line of output. So that was not what you practiced in homework 1, and we only saw it briefly at the end of Monday's lecture, but I'm just kind of reminding you that's the switch we're going to be making, is using system.out.print for the individual characters that are on a line, and then a println that completes the line of output. Well, so this is a little more specific. I can get rid of what we had here. That was to replace that. That kind of, now I'm being a little more specific about how that's supposed to work. Print some equal signs. How many? I could be more specific, right, about how many equal signs. Now, different people will count things in different ways. I'm old school. I like to use the cursor and everything, and I like to use my arrow keys. So I like positioned right there, and I can go 1, 2, 3, 4, 5, 6, 7. So that's how I count things. But there's a really nice feature of the output comparison tool that my co-author Marty Stepp built into it, which is that if you select a bunch of text, it says that's 16 characters. In case you're doing homework 2, and you need to be able to count how many of each of those characters there are, I'll tell you. So the output comparison is very helpful in kind of telling us that. So more specifically, not just some equal signs, 16 equal signs. I want to print 16 equal signs. How do you do something 16 times? Now, remember, we're going to want this to be done in a flexible way so that we'll be able to scale it. The thing is that, the solid line that you have, if you look at this mirror right here versus this mirror right here, it's not surprising that the lines are of different widths. The line, that line is going to have to scale. So it won't always be 16 equal signs. It'll be a different number of equal signs different times. How do you do something kind of a different number of times? That's what for loops are for. So that's where the for loops come into play. So what I'm going to say is, let me kind of say, for int I equal 1, how do you do something 16 times? I less than or equal to 16, I plus plus, and then inside of here, the thing that you want to do 16 times. That's how you do something 16 times, right? I'm just kind of being more specific than what the pseudocode said. So I'll say print an equal sign. So you could see that I'm kind of getting slowly but surely closer to something that looks like code. So I don't know whether this approach will help for you guys or not, but it's something that we often do because it can be a little overwhelming to try to see all of the detail at the very beginning. Now I know that this, basically what I want here is system.out.print with a quote. That's going to be the way to say it in Java, and so I'm going to kind of do that here, that it's a system.out.print. I'm going to do that here, that it's a system.out.print, and then those things have to have a close quote, right paren, semicolon. So I got to have those characters too. All I did here really was just decide that, I was going to be more specific than just the word print. So now, it might have been helpful to just say print so that for my own sanity, I wasn't worrying about it being code. But if we're trying to turn it into code, then we want to be, getting it closer and closer. System.out.println, and that would have this. And I think I've turned it into code. We kind of did it in these little stages, but I think now it's code. I guess we can find out. So I can take these different lines that I have right here and make a copy. And I can come over here, and I can go to the drawLine method, and I can paste them in. Now, that's at the wrong level of indentation, and you could lose points for indentation mistakes. So we don't want to do that, but JGrasp has a nice feature where I can select a bunch of lines like that and hit tab, and it tabs it over 2 spots. And if you even tab too far, what am I going to do? Shift tab brings it back. So tab and shift tab are a nice way to change the indentation of things in JGrasp, to move it this way and that way, a whole block of code. I think, did you guys, I think that's a capital Y if I'm reading it correctly. But let's go ahead, well, we'll find out. We'll ask the compiler if it sees any problem. Doesn't seem to. I can ask it to run, and what we get is this, right? Not a lot of output, because we only wrote one of the methods, but it's something. I'm going to make a copy of this right here. I'm going to come over to output comparison and paste it in, and I'm going to say compare. You dummy, you missed all this stuff. Oh, no, there's a bunch of stuff we didn't do, but it's not complaining about the equal signs. Right? The hashtag equals, it's not complaining about those. This is actually good news. This is we've made progress. It may not feel like progress, but it is. Hey, sometimes there's confidence building and everything, right? I do think that, that in doing that, going through that exercise would be a useful thing because it would help you to verify, am I doing the for loops correctly? Am I doing the print and the println correctly? Did I understand those things? So, we've actually accomplished a fair amount here to make sure that we got that part of it right. And it's good to make, if you did have a misunderstanding about for loops or a misunderstanding about print or println, better to fix it now than to kind of, have written everything with that misconception. So that's why kind of doing this much of it and then making sure it works is a good idea. Let me just mention briefly that the term that I use with the TAs when we talk about this is we talk about the idea of a development strategy. That, that whenever you're approaching a problem like this to solve, you want to think about what will I do first?
what's the first little piece of this I'll solve? And then what's the next piece I'll solve? And then what's the next piece? And you kind of have a strategy for how you're going to produce this program step by step by step. And what I've told the TAs is that they are allowed to talk to you endlessly about your development strategy. So if you wanted to say to a TA, I've come up with a development strategy for homework 2, does this make sense? They can tell you. They're allowed to talk to you about that and say whether that's a good idea, not a good idea, rearrange the order, or do something different. You are allowed to absolutely ask for that kind of assistance from the TAs, because I think it's hard for beginners to always know how to do these development strategies. Those of us who've programmed a long time, it's so second nature to us now that we forget that at some point in time it wasn't so obvious. So please take the opportunity, and I ask the TAs to turn it around for you guys. Like if you go into the IPL and you say, I'm totally lost on a homework 2, I don't know where to begin. One of the things that I might ask you as a TA is, what's your development strategy? Have you thought about that? What are you going to try to do first? Which part of it are you going to try to do first? And it should be a small piece of it, not the whole thing. So anyway, that is incredibly important in terms of being able to manage all of the detail without having your head explode, believe me. Okay, well this is the harder part, is to kind of do the things that look like this. Now, I think that one of the things that makes this harder is that when you have just one for loop, I think that's not so challenging. I think people don't struggle so much when there's just a single for loop. But this is going to have nested for loops. The reason it's going to have nested for loops is there's a whole bunch of complexity within a line. So producing a line, it's going to involve for loops, that have complexity. And there's more than one line. So there's got to be a loop for line 1, line 2, kind of an outer loop that gets you the different lines, and inner loops that get you the pieces of a line. So that makes this harder. That's why this part's going to be more challenging. I guess maybe what I would say in terms of some good news is that we're not asking you to be terribly exotic with the nested loops that you're doing. Your loops are going to look like the loops we're about to write, and the ones you'll do in section, and the ones that are in the book. So you could have lots of examples of this kind of a nested for loop, but it is a nested for loop, and that's kind of one of the things that makes this a little harder. So, you could, pseudocode could be something like, for 4 times, what I want to do is print 1 line. There's going to be, I think that it is important to understand that the big structure here, kind of the outer structure of what's happening, is a for loop that executes its body 4 times, so that we get line 1, line 2, line 3, line 4. That's the outer structure, the overall structure of what's going on. And how do you do something 4 times? Well, we've seen all those nice little, for int I equal 1, I less than or equal to 4, whatever. It's a formula, right? The book tells you how to do exactly what kind of for loop to write to do something exactly 4 times. I'm going to be a little different with this for loop, and I'm going to use a different variable name than I. I, J, K are common variable names, but here I'm going to use the variable name line, because I think it's a little more meaningful. I could have used I. I think it's a little easier to say for int line equal 1, line less than or equal to 4, line plus plus. So just instead of it being I made it line, line, line. So I have a different named variable, because that makes more sense to me. Line is going to be 1 the first time through, 2, 3, 4. So it's a way of knowing exactly what line number I'm working with. And again, this is the pseudocode approach. You would kind of be thinking about, all right, this is my starting point. There's an outer loop that goes 4 times, printing 1 line at a time. What do you know, by the way? So this is a funny way. This is a funny way to start this. But if you're going to print, if you want the code we're going to put here to produce exactly 1 line of output, then one of the things that is it's going to be print, 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 ending in, to get 1 line of output, println. It always ends in println. You kind of know it ends in a println that's going to complete the line of output, right? If going through all the steps is supposed to produce a line, the way you produce the line is, from Java's point of view, it does print, 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 and println goes it goes to the beginning of the next line. So you kind of know that it's got to end with a println that's going to complete the line of output,
but we got to figure out kind of all the things that come before. So what are the things that come before that println? So this is a fairly mechanical process that you can do yourself with the rocket ship. So you can do this with the different lines of output there on the rocket ship, is just look at a line and kind of look at it from left to right. So all right, well, let's look at this line right here. Just going across from left to right, what is the very first thing that gets printed on this line? There's this vertical bar character, right? I mean, we want to print a vertical bar character. Do we ever print more than one of them there? No, there's always exactly one of them at the beginning of the line. Now, one of the things that I think for loops, somehow, learning for loops makes people forget what they knew before for loops, which is if you want to print something just once, just say print. You don't need to make a for loop to do something once. So, and in fact, you would lose style points if you made a for loop to do something exactly once. If something only happens one time, don't put it in a for loop. We want you to make a distinction between things that happen once and things that happen more than once. What do you print? What comes on the line? What comes after the vertical bar character? Spaces. Well, I don't see any spaces there. So kind of, right? I'm going to say possibly 0. All right? That way it's always true. That's a number of spaces. It's just 0 spaces, but it's a number of spaces. What comes after the spaces? There's a less than, greater than. That's not less than, greater than. How many of them? 1, exactly 1, exactly 1. No loop for that, exactly 1. Then what comes after the less than, greater than? Some dots. What comes after the dots? Another less than, greater than. What comes after that? More spaces, possibly 0. By the way, the dots can be 0 too. So I mean, anyway, but we're trying to come up with a general rule that describes these different lines, and some of them have spaces, some don't. Some have dots, some don't. And then what comes after the spaces? Another one of those vertical bar characters. So what I've done here is I'm just kind of, this is a mechanical kind of thing where you can just go across the line. It begins with one vertical bar character, then some number of spaces, but it's different on different lines, then exactly 1 less than, greater than, then some number of dots, but different numbers of dots on different lines. I think you can tell the dots or the things, different numbers on different lines, that's going to be loops. That's going to become for loops eventually. But we're doing it the pseudocode way where we don't worry about that just yet. Exactly 1 less than, greater than comes after that. Some number of spaces, but different numbers of spaces on different lines. Exactly 1 vertical bar character, and then complete the line of output. So this list right here, you come up with just by reading across the line, just by analyzing the different elements that are there on the line. It's a lot. I mean, there's a lot of different things that are there in that sequence, but the process of coming up with it is just examining the line and coming up with this description. Okay, now these things that we're going to do once, we don't need a loop for, but the things we're going to do spaces, I don't know how many spaces, different numbers of spaces, those things are going to become loops. So I'm going to say for int spaces equal 1, spaces less than or equal to something, spaces plus plus, I want to print, I'll just say print space. But that's what I mean when I say print space. I mean, this is closer to Java. It's closer to Java code. You notice, again, I'm not using I. I'm using a variable called spaces. All I really did there, this isn't Java. You can't say question mark, question mark. I mean, that's just kind of like Java, you figure it out. No. I mean, Java's going to insist that we figure it out, and that's hard. That's going to be a hard thing to figure out. So don't get me wrong. We're going to take time to figure it out. But the way you print spaces, it's kind of a certain number of spaces, is to make a for loop that prints 1, and then the for loop goes a certain number of times. And it goes different numbers of times, for different lines. So it is going to be tricky to figure out what the question mark is, but the for loop itself is pretty straightforward. I mean, the idea of a for loop is pretty straightforward. In fact, all right, so I'm going to copy this from here, and I'm going to replace this with that. In fact, I'm even going to replace print dots with that and change this to print dot. That basically, there were 3 things on this line. The leading spaces, the dots in the middle, and the trailing spaces.
there were 3 different times where the number of those things would vary from line to line. So how many spaces there were on the left, how many dots in the middle, how many spaces on the right. Those were the things that varied from one line to another. So they were the things to include in for loops. It's getting pretty close now to this being code. I mean, we still have to figure out what these question mark things are, but we can do the kind of thing we did before, which is I want that to be system.out.print with a quotation mark. So all of these things where I'm trying to print something once on the current line, I can just replace print with that. So I'll do that here, I'll do that here, I'll do that here, I'll do that here. All I'm just doing is just kind of turning that word print into something that's a little closer to actual code. And then I'll do that here. And we got, well, this becomes system.out.println. And then all of those things needed a close quote, right paren, semicolon. So we kind of needed to have all of that there. So I'll copy that and paste it there, and paste it there, and paste it there, there. And this one is the simple print that looks like that. Getting closer. I use the word space here because you wouldn't see a space. I mean, if I had an actual space there, you just wouldn't have seen it. Now that we've got quotes in there, you can actually see the space. But I think that's pretty close. I think we've got pretty close to, I've changed things into code that are easy to change into code. What's left is figuring out kind of the hard part of this, which is those inner for loops. How do we get those inner for loops to produce different kinds of spaces, dots, and spaces? That's the part that's left. But let me just kind of pause for a moment and reflect, try to get you guys to reflect on what we have here. Because this is a ton of detailed code that we've written. But again, what I would claim is that it's a fairly mechanical process I use to get us here. Is that we just kind of analyzed what was in the line, and things where it was a variable number of things in the line, we turned them into for loops. So we know we want for loops there. We just haven't figured out how many times the for loops should execute. But otherwise, the basic form comes from just analyzing the text of the line. All right, let's talk about what to do with those for loops. So we have a variable called line, which takes on the values 1, 2, 3, and 4. Those are the values that line takes on. We have to figure out how many spaces to have on the left-hand side of the line, how many dots to have in the middle, and how many spaces to have on the right-hand side of the line. That's what's left to figure out. So I want you to make a table, or at least this is, again, a mechanical process you can follow. The chapter describes it. The TAs will describe it in section tomorrow. I mean, if you can figure all of this out in your head, you don't need to do what we're about to do. That's great, but a lot of people kind of need this. What we're about to do is something out of a class you might have heard of called Algebra 1. So I don't know, some of you wincing, some of you whatever, I don't know whether you have pleasant or unpleasant memories. If you remember the idea of slope intercept, y equals mx plus b, that's what we're about to do. We're about to use algebra. Yeah, you were supposed to remember it. But turns out you don't really have to remember, whatever. We'll show you how to do it even if you don't remember algebra. So if it's helpful to you to think of it as slope intercept, great, think of it that way because that's what it is. And if it's not helpful because you hated that class or you've forgotten everything, don't worry, we're going to show you how to do it anyway. But the tables, I think, are very helpful. So what I want to do is I want to count how many spaces there are. So like on line 1, 1, 2, 3, 4, 5, 6 spaces here. And then here there are 1, 2, 3, 4 spaces. Here there are 2 spaces. And here there's 0. So that was, what was that again? That was 6 spaces here, 4 spaces here, 2 spaces here, and 0. You could use the output comparison to do this counting. It's going to be important that you do the counting right, in order for these things to work out. But that's a next step in kind of making a little table here. What about the dots? What we have for the dots is that there are 0 dots on that first line.
This second line has 1, 2, 3, 4 dots. This line has 1, 2, 3, 4, 5, 6, 7, 8 dots. This one, I'll just tell you, has 12. You know, that might be worth going back to the output comparison tool, but there's 4 dots there, there's 8 dots there, and there's 12 dots there. It also turns out that there's a symmetry to this thing. So if there were 6 spaces on the one side, there's 6 spaces on the other side. So these numbers are actually the same. You know, you could verify for yourself if you want to do 1, 2, 3, 4, 5, 6. You know, they make sure that it's the same. But anyway, it's the same on the left and on the right. What we want to come up with now, mathematicians would call it an equation. We call it an expression. We're trying to come up with something to put in the question mark, to kind of replace that with. So we want to come up with an expression. Now here's what and there's 2 steps in doing this. So the first step is to come up with a multiplier. So if I notice that line is going up by 1 every time, how is spaces changing every time? It's going down by 2. So how do you turn something that's going up by 1 into something that will go down by 2? You multiply by -2. So the multiplier is -2 because that's how this thing is changing. So -2 times line, if line is going up by 1 as this loop goes through, this is going to give us an expression that goes down by 2 every time. That's slope. You know, we don't have to call it that, but that's what it is. Now we want to throw in a number that makes us get the right answers. When line is 1, -2 times 1 would be -2, but we want to get 6. So what do I have to add to get a 6? 8. Right. That's the intercept. That's the thing that, you know, we're kind of setting it so that it comes out to be the right thing. Dots, they're supposed to be 0 on the first line. You know, as line goes up by 1, you can see that dots are going up by 4. Again, multiplier first, the multiplier is 4. To turn something that's going up by 1 into something that goes up by 4, you multiply by 4. So 4 times line will go up by 4 every time. When line is 1, this would give us a 4 when we want to get a 0, so we could do -4 is the thing to kind of have it be a 0 for the first one. Some people would rewrite their loop so that line started at 0 to begin with. You know, that's another way to go if you wanted to. You could kind of do it in a different way, but it works no matter what. You know, this technique always works. You come up with a multiplier and a constant, and you come up with an expression that varies the way it's supposed to. This spaces thing is the same kind of expression as what we have right here. So what I can do is I can take this expression right here. This was how many spaces I want, and I'm going to go right here, right? Because isn't that the part of the for loop where you say how many times to do it? You know, do it n times. That's the thing. Yeah. The 4 times, oh, here. So we had to do the times 4 to get it to go up by 4. But if I'm thinking about that very first row, when line is 1, the expression 4 times line gives you 4 times 1, which gives you 4. And we want to get a 0. So how do I adjust it so that it becomes a 0? I've got to subtract 4 from it to have it turn out to be a 0. And one of the things, this, by the way, you're going to practice in section. This, but you know, you could verify. You can plug the line into, you know, to this little expression, you know, for all these different values to make sure that it does just the right thing. So now let me see. I think I was on the verge. Let me make sure I did it right. So let me copy what I think I already did, but let me do that. I'll copy what I have here, and I'm going to kind of go right here in the for loop, and I'll put it in parentheses just because it's a little easier to see then. This is the end. This is how many times I want that loop to execute. That's how many spaces. And I wanted to do that also. Oh, man, this is all screwed up, and you guys didn't tell me. I'm sorry. We'll fix that. We wanted to do that here. Well, I mean, it's not necessarily a problem, but I mean, if it's a loop that's making dots, let's call it dots, not call it spaces, right? So, I mean, it's just a better variable name than to call it, I mean, it would have worked. It's just, this is a better way to go. Now, this is how many dots we wanted, 4 times line minus 4. So I'm going to make a copy of this little thing right here, and I'm going to come down here and do the same thing. So I think actually, yeah, we're done. Yeah, go ahead. So that's it. So the question was whether I could do spaces minus minus. So there's a lot of things you could do to change how the loop works. Like we talked about, line could start at 0, things like that. So you were wondering, what if we made spaces go down instead of going up or something like that? You can. So there's a lot of other approaches.
I kind of am showing you a mechanical way that always works. You know, starting at 1 and going up to a certain thing. This is a technique that always works. But if you find this other way of writing the loop that gets the same result, that's fine. I'm just kind of telling you that this is I am telling you a guaranteed way to always be able to solve these so that it'll work. Yeah, question here.
Would you lose style points for doing it a different way to get the same output for something like this?
In general, no. In general, you can do it a different way, yeah.
Is it considered redundant to have the two different forms that do the same thing?
It is, and it's not something that we're going to understand until Friday's lecture. So what I would say is fantastic instincts, and we'll save it for Friday, okay? But we're going to talk on Friday about why it's so, but it's why it's okay to do this evil thing that I'm doing. Let me come here. Let me try pasting this code in. Let me go here. I'm going to select all these things, and I'm going to tab so that I can kind of do this. Let me compile and run this version of it. And now what I get as output looks like that. And I can take these lines right here, and I can copy it, and I can come over to output comparison, and I can replace what I had there with this, and I can do compare, and I've got everything except for the lower half. So that's good. I mean, I'm kind of making sure that it's working right. All right. I want to do a few more things. I do want to comment on something that I've done here that's not considered the best style. So so most programmers would not write this way, where they do a simple print followed by a simple println. They put the two of them together. Because it turns out that if I say println, and then inside of here I have the hashtag, that's exactly the equivalent to what I had there before, is that it does the simple print on the current line. It prints that text on the current line, and then it does the println that goes to a new line. So it's a minor style issue, but we would kind of prefer that you combine the print and the println like that, so that this would be one thing rather than two. So that's a minor thing. And then we're going to do kind of the major thing. Well, we haven't done the lower half, although I don't want to worry about the lower half just yet. What did I do? Something that, oh, maybe this one hadn't been tabbed over. I think that's why that. I want us to talk about the scaling, because this is a hard part. Well, all of this you're going to find challenging. You know, I'm trying to kind of lay out to you guys these nice mechanical procedures you can follow, but you're not going to really learn this until you do it on your own, until you do the rocket ship program. The TAs will help you tomorrow by going through some problems in section, and you'll get a little closer, but really you learn this by doing. And so the lecture might be helpful to be able to review and come back and remind you of all of this, but I know there's a lot in this lecture, and we're about to amp it up a little more. So this is going to go a little faster than is comfortable, and this is another reason, by the way, the part that I'm about to do, the scaling part using the constant, don't do that first. Get a thing to work right. Get a rocket ship to work right so that you have one rocket ship correct. Then worry about scaling it. So, I mean, I've done all but the lower half, but I still want to start working on the scaling because that's kind of more important. So what we're going to have you practice is introducing what's known as a constant. Public static final int size is equal to 4. So this is a way of introducing something into a class that's known as a constant. The capitalization convention is that you use all uppercase letters. That's why I did size and all uppercase letters. The word final there means that it is truly a constant, not a variable. No one is allowed to ever change it. It'll always be 4 for the duration of this program. And all of the methods are going to be able to know that size has a value of 4. What we're going to do is adjust our loops so that they incorporate this size. So that way, if I change the size to 3 or 18 or 27, it'll adjust the mirror appropriately. So that's what we're going to do next. So one of the adjustments is a little easier, which is that here, you know, if we're doing the solid line, let me just kind of write down what we had here. So we have a size of 3 and a size of 4. And the thing that I'm wondering about is how many equal signs are there? Do you remember how many equal signs we had when it was a size of 4? There were 16. And we could count here, you know, or use the output comparison to count for us. And what we find is that there's 12 of them, that there's 12 equal signs here. So we wrote a for loop that used the number 16, but we don't always want to use the number 16. You know, so what we really want here is an expression
that adjusts with size. And it may sound a little odd, but it's the exact same trick again. Before, what we were doing is we were looking at how line changed and coming up with an expression that involved line. Now we're going to look at how size changes and come up with an expression that involves size. So look, if size goes up by 1, it goes from 3 to 4, and this goes up by 4, there needs to be a multiplier of 4. So you need 4 times size in order to have something go up by 4 instead of going up by 1, or to turn something that's going up by 1 into something that goes up by 4. And 4 times 3 is 12, 4 times 4 is 16, so we don't need a constant. We know it's 0. We don't have to adjust it in any way. So I can take this little expression right here, 4 times size, and I can come over to the program, and where I had a 16, I'm going to put 4 times size. That's how it's going to scale. That's how the solid line is going to grow and shrink as size is changed. So that's kind of an adjustment that I want to do. Well, in fact, I can even show you. I mean, if we could compile and kind of make sure that it's still producing what it did before. But now if I kind of change the size to be 3 and go ahead and compile and run it, you're going to see that now the solid line is skinnier than it was before because it's as if it's doing it for the size 3. So we haven't fixed the other parts, and that's why the other parts aren't looking right. But now what we would want to do, you really can just do the tables all over again. So here, let me show you. Here's the size 3. So I can say, look, line goes 1, 2, 3, and so I can figure out here how many spaces are there and how many dots are there. So how many spaces are there here? 1, 2, 3, 4. How many spaces are there here? 2, 0. So it was 4, 2, 0. That's what we want this to be, 4, 2, and this one was supposed to be a 0. And then how many dots? There's no dots on that first line. If you counted, you'd see that there's 4 on the next line, and you'd see that there's 8 on the next line. So I'm just going to solve this all over again as if this had been the problem. So I'm just going to kind of figure out what would be the right expressions to use as if this was the problem that I was solving. Here, spaces is going down by 2 while line is going up by 1, so it's got to be minus 2 times line. When line is 1, I'd get a minus 2, but I want to get a 4. So what do I add to it? 6 to turn a minus 2 into a 4. Dots are going up by 4 every time while line goes up by 1, so it would have to be 4 times line. That would give me, when line is 1, that would give me a 4 when I want to get a 0, so I have a minus 4. So this is as if I had just solved a brand new problem. I just kind of worked out a brand new problem. But now here's kind of the place where it's getting a little tricky, but it's basically just using the same idea. I want a table that involves the changing size, the different sizes. So I want to think about size 3 and size 4, and I want to think about how many spaces to have and how many dots to have. And this was what we came up with when it was a size of 3. That's what we came up with for a size of 3. And I can just go back over to here to what I'd done before. This is what we came up with for a size of 4. And so I can put this right here. And I now know that basically I can see what kinds of things stay the same and what kinds of things need to adjust. It's always minus 2 times line, right? So that stays the same. But what I add to it is different. So in the one case, I'm adding 6. In the other case, I'm adding 8. As size goes up by 1, goes up from 3 to 4, that number that I'm adding goes up by 2. So in order to make something that goes up by 2 when size goes up by 1, I have to have 2 times size. And it really is just the same thing of coming up with a multiplier and a constant. When size is 3, we're supposed to get 6, and it turns out that 2 times 3 is 6. When size is 4, we're supposed to get 8. 2 times 4 is 8. So we don't need to add anything or subtract anything. It's kind of giving me the right thing. These equations, this didn't change. 4 times line minus 4 didn't change. So really, the only thing that has to change is the place where we had used an 8, we want to use 2 times size. That's how it differs, is that the place that had an 8 would become a 2 times size, and everything else is the same. So I can come back over here. Let's see where I had that 8. I had that 8 right here. So the 8 should be replaced with 2 times size. And then I had the 8 down here, and that should be replaced with 2 times size.
So the other things stayed the same. Let's try compiling and running it. And we get something interesting, which is we get almost that other mirror, but what's going on right there? Why did that happen? Well, I mean, you see it there on your screen. Remember, we haven't talked about it for a while, but there's an outer loop. Remember that there's an outer loop that generates the different number of lines? And how was that outer loop written? We said 4 lines. That's how many lines it should be. But we're introducing a constant here for the number of lines. And so if I want to be able to change it from 4 lines to 3 lines to 18 lines to however many lines, I have to use size there as well. I need it in the outer loop as well, because that kind of is changing how many lines are being produced. And if I kind of do this, now I'm getting the thing that's size 3, and I can come up here and I can say, how about size 9? And I can compile and run that, and suddenly I'm getting a mirror that's got, that's that size, and it's scaling properly. So that's how that's done. Now, let me say it again. The constant is the hardest part. Save it for the end. Get everything else to work right first, and then figure out the constant. It might not be a bad idea to come back to today's lecture online and watch these last 10 minutes, when you've reached that point, to kind of remind you about how the constant works. But it really is just reusing the idea that we had before. I got a few more minutes left that I do want to take the time. I wanted us to kind of finish a little bit of what's left in this program. This particular, so we didn't do draw half 2. So there was kind of draw half 2 was left in all of this. So if we kind of look at the way these things work, these lines right here, this is line 1, 2, 3, 4, they're really exactly the same as what we have here, but what's the order if those were the line numbers? This is 4, 3, 2, 1, right? It's just the same lines, but in reverse order. So I'm going to do something here, which is kind of an easy way of getting this to work, which is I'm going to take all of that code that we wrote, I'm going to make a copy of it, and I'm going to paste it in here. I'm going to talk to you about this, by the way, that when you find yourself doing copy-paste a lot, you should feel that that's dangerous and bad and immoral. That there's, the copy-paste, programmers don't like to do copy-paste. And so, in general, in fact, I feel a little dirty right now. I'm gonna probably have to go take a shower or something after this. But anyway, we're going to talk a lot about this. But I'm going to just say line starting at size, line greater than or equal to 1, and line minus minus. I'm just going to have it go in the other direction. And let's set it back to a size of 4, which is what we had originally. I just kind of want to see whether whether we managed to produce the complete mirror, which we did. So it may be the case that things are like in an exact reverse order, may not be. If someone was making up a programming assignment, they probably would have the lecture example be simple, but not necessarily the programming assignment. So this isn't necessarily going to be so easy for you guys when you go from half 1 to half 2. I want to make one more point, just this one more point, and then I'll let you guys go. I mean, I got at least a minute and a half here, I think. I want to repeat a question that someone asked, and just to let you know, so there are lines of code right here that produce a certain number of spaces, and that for loop now appears, that exact for loop appears 4 times in this program. Horrible redundancy. It was great that someone said, shouldn't we get rid of it? It turns out it's hard to get rid of it, and that we need things from chapter 3 in order to get rid of it. It's going to be the subject of Friday's lecture, but I did kind of want to point out that in homework 2, there's what we describe as within line redundancy, kind of the left side of the line and the right side of the line. So you are going to have some little bit of redundancy like this in homework 2, and it will be okay. You can just refer back to the calendar and see that we had done something just like this in lecture. Okay, I'll let you guys go.
Hello, I'm Sherry.